In this video, I want to introduce you to the property of congruency. All right. Now, I'm going to start by first talking about another word that you're probably more familiar with. So, in algebra, you said that quantities were equal, right? So, like 1 plus 1 is equal to 2. Or you would say x is equal to 3. All right. 5 is equal to the square root of 25. All right. Now, what those all have in common is both sides of the equation have an expression that evaluates to a quantity. Okay. When you say things are equal, we're saying that two quantities are the same quantity. Okay. Now, in geometry, we work with figures, right? Suppose that I had a shape like a tile for a floor, and then suppose I had another one that was similar. Okay, so I'll make another tile here, and if I measured both of them, if I measured the different lengths and the corresponding lengths were all the same, and so I put them right on top of each other and all the points lined up, okay, then I would be tempted to say that, well, they're equal. All right. Now, people do say that, but there's one thing that's not quite so perfect about saying that tiles are equal, and that is that really we were using the word equal for quantities, right? But now we're using the word equal for something that's not a quantity. There's really no number associated with a tile. I mean, you could say that the lengths are the same because a length is a quantity, all right? But saying that two tiles are the same, a tile is not a number, okay? When you have a shape and you want to say that there's some resemblance between two shapes, okay, two figures, we say that they are congruent. Okay, so the reason we have this new word is because we want to be very careful and precise with our language. When shapes have this commonality, then we'll say that they're congruent instead of being equal. All right. Now we have to now specify what properties have to be true for things to be congruent, and we're going to have to specify for each different shape that we use, we're going to have to specify what it means to be congruent. Okay, so so far we've talked about lines and angles. All right, let's start with those. Lines and angles are congruent. Or let's just do lines. Two lines are congruent if they have the same length. Okay. Two angles are congruent if they have the same measure. So the same number of degrees. All right. That's what it means for lines and angles to be congruent. Okay. Just to show you how things could be different and still be congruent. All right. Suppose I had a stick, a blue one that was a certain length, and suppose I had a purple one, and the purple one was the same length. Are those congruent? Yes, they are. The point I'm trying to make is that the color doesn't matter. The congruency doesn't say that absolutely everything has to be the same. Only the length has to be the same. Okay. Now, here's another way that they could be different. All right. Suppose I had let's say I had the blue stick, and now what about if the other stick was blue? So it's not going to change the color, but this time it's not at the same location. Okay. Those two blue sticks, are they still congruent? Yes, because they both have the same length. The location doesn't matter. Okay. One last thing. Suppose I take the congruent stick, the second one, and suppose I move it around. So now it's kind of inclined differently, like this. See that? Okay. Are those still congruent? Yes, because the orientation doesn't affect congruency. Okay. So let me emphasize that, and then I will close. Okay. So congruency does not depend on unmentioned properties, unmentioned in the definition, okay, like color, okay, position, orientation. The point is that the red definition never mentioned color, position, orientation, or a lot of other properties. All it cares about is length. So the length, if the length is the same but a bunch of other stuff is different, they're still congruent. Okay? And for the angles, if the measure is the same but a bunch of other stuff is different, those angles are still congruent. And then later on we'll learn about how to show that other complicated shapes are also congruent. All right, they'll have their own specifications.